In the previous video, we talked about how to use computable properties with structs. And to the end of the video, we then showed you a little bit of an insight to extensions. In this video, we're going to show you about how to extend structs. And by the end of the video, I would have also introduced you slightly to protocols as well. So with that said, let's just jump straight in. Now, this is going to be a little bit of maths in this, but don't worry about it. You don't have to really know the maths. You can just trust me on it, right? So the aim of this is to be able to convert this one position into a vector. All right, now, but we need to do a little bit of mathematics first of all to work out what do we need for a basic vector. All right, well, first of all, we need to know the angle. All right, the angle of where the vector is going. Okay, and let's just put this 0 for the time being. And we need to work out the magnitude of the vector 2. Okay, and we're just going to say 0. So once we know the angle of the vector and the magnitude of the vector, right, we also need to know then the center point. All right, the center point where the vector basically is sitting. All right, so we've got that, but we don't necessarily want to make a vector struct, okay? Because we've got a position and an origin. We want to pass something on that is as lightweight as possible. So before we talk about that, obviously that's going to be then protocols, which we're going to show at the end. But we want to extend position. Now, why would we want to extend? Why don't we just add? Why don't we just add this information here? Well, we want to go on the principle that this is closed for modification, right? But open for extension. And which means that this position struct could be implemented elsewhere. It may be that you don't own it. Well, in this sense, you definitely don't own it, or the person who declared it said this is basically final. You cannot change this. All right, your work colleagues or someone said no, a position only has an origin, width, and a height, and you're like, no, I need a vector. We need to change it, right? But you need to create a vector for your code, all right? So how can we extend this? Well, we've already seen extension, but we're going to look at it a little bit further, right? So what we want to say here is that we're going to say extension, and then we're going to say position, all right? And this position, we know that we want to create the angle, all right? Well, in the previous video, you saw computable properties, and we know that we don't want to set this angle because we want to use trigonometry to work out what the actual angle is with the information that we've been given already. And well, with the angle, it is quite easy to do that. And all we need to do is we need to take the inverse of tan, all right? And in this, we're then just going to say then the square root. So in this, we want to then say the opposite, which we know already, over then the adjacents. So we then want to say the width over the height, and that will then give us the angle, because arctan is taking basically the ratio between the two, and it's going to then give us the angle. Now with the angle, so let's just test this whilst we're there, just to show that we are working perfectly fine. And we say then position and angle, and we run this, and we get 0.78539881, this, that, and the other. And if you're not aware of what that is, well, let's just come and show you a little bit further and say double.pi divided by 4, and we run this once again. And you can see here that it is double.pi /4, and this is then working out basically 45 degrees in radians, all right? So let's just get rid of this once again. So now that we've got the angle, we now need to work out the magnitude. Well, if you go back to your trigonometry days, you should be able to work out the magnitude pretty easily. If not, don't worry about it. You're going to see it right now. Well, we know the width and we know the height. Well, we want to know the hypotenuse, which is then basically just going to use then the square root, right, of a squared plus b squared, all right? And we're saying square root because we want to reduce it down to the actual value. And so now we're just going to say the power of the width to the power of 2, right? A squared plus b squared. And then we say the power of the height to the power of 2. And this will now give us the magnitude. So let's come here and let's say this, and we'll say magnitude. And when we run this once again, you can see that we've now got pi over 4 for the angle, and then the magnitude of it is 1. This is a unit circle, all right? It's a unit circle with the angle of 45 degrees, or pi over 4, and then it's a unit circle, so it's got a radius of 1. So now we have this. This is super cool. And now let's just say, like, get vector, right, of, let's say, position, and we'll say position, and let's return a vector, right? And you're like, oh, wait a minute, we don't know what a vector is right now. So this is where protocols come into play. We don't necessarily need to create a new struct, right? We can just create a protocol that takes the implementation already and then returns a protocol from that. And a protocol doesn't have any implementation. It is just saying, hey, this is the blueprint. This is the things that it should have, it must have, but look, I didn't implement it. I'm just telling you what to implement. So we can say here that a protocol of a vector, right? Well, it already said what it's got to have. It's got to have an angle, right? It's got to have a magnitude. And in this sense, it's got to have a center too, all right? And we're going to say that's the origin of it. Now, you're going to see the compiler give us a compile time error here because we haven't explicitly set a getter or a get or a setter here. Now, we know already through computable properties that we are the angle and magnitude are get only, they're read only, because we haven't defined the set here. So we know that on all of these, we only want to use the get, and we do that just by using then the curly braces with get inside of it, and then get inside of it. And this is telling our implementation that you need to implement only the getter, and this vector should only have a getter on the center, angle, and then the magnitude, all right? So now how can we return, let's just return a position here. Another compiler says return expression of position does not conform to vector. Well, this is the magic once again of extensions, because extensions can also help you to implement a protocol, all right, or multiple protocols. And you can see here position type position does not conform to vector. That is because our origin, right, is a setter, has a setter as well, right? So, but we called it origin. So here we need to say center is then origin, and here we can then say origin, right? And you can see now that the compile time error goes. So now when we look at this, we can then say vector is equal to get vector of position. And when we now print the vector, you can see now that we get we now get position origin here. So this is the implementation that is being printed, all right? But we only know about, when we try and use it, we only know about angle, center, and magnitude. See, we don't know about origin, but when it got printed, we saw the implementation that's got printed instead, because the compiler actually knows what the implementation is, but our code only knows about the, this vector only knows about the protocol itself. So it means we're able to hide implementation by passing on protocols, and this is a magical thing that you can use, and it will be used in a lot of places as well, in a huge amount of places when you start doing the likes of, well, 100% when you start doing Swift UI, all right, and when you start doing other different things. So with that said, this is now showing you about how to extend structs using the extension keyword. We've also highlighted to you here about getters and setters. We've also highlighted then protocol, and we've showed you a little bit about how about mathematics as well. With that said, I hope that you've got something out of this one video. I hope this has inspired you. I hope this has inspired you to enhance your mathematics. If you want to get into the likes of machine learning or this, that, and the other, then this is probably going to become quite a pertinent thing for you to understand the unit circle at least. Other than that, thanks very much for watching. If you do have any questions, comments, concerns, or anything like that, then let's start a conversation in the comment section down below. Yeah, my name's David Thorne, and I'll see you in the next video. Ciao, ciao, and goodbye.